Hey everyone, I hope you're doing really well. This year's going really fast and we're already on to Mindshifting May, which is probably the month I am most excited about this year, mainly because it includes Prolog, which is one of my favourite programming languages. I hope you enjoyed Analytical April. If you took part in that, absolutely loads of you did. I think it was one of the most successful months we've had so far. I also had the privilege of chatting to Simon Peyton Jones OBE during April as a late functional February interview. That was really fun, really interesting and inspiring, and I definitely recommend watching that back if you didn't see it live. There's a few others with other language creators as well. Now we've had C++, we've had Rust, Elixir, Gleam, someone from the Go team. So there's loads of great content there that I really recommend watching back on the channel if you've not. My favourite line, and I think the whole interview is worth watching back just for this one line by Simon Peyton Jones, was when the limestone of imperative programming is worn away, the granite of functional programming will be revealed underneath. And it was interesting to see his whole career in functional programming, which has not been the most popular thing. Haskell, he's the creator of Haskell, if you don't know, or one of the lead developers of Haskell. It's not been the most popular language forever. It's been very academic, but now functional programming has this huge resurgence. Yeah, to be at the forefront of that and see your whole career sort of coming to a pinnacle, I think has been really exciting. So I thought that was a lovely line, and a couple of people have commented on that as well. But anyway, on to Mindshifting May. So normal video, Erik and I are going to be giving you a quick overview of what the month's about and the different languages we're going to be exploring. Hi Erik, how are you doing?
Hi Jeremy, I'm doing well. I'm really excited about this month.
Yeah, me too. I think probably in the whole year it's the month I'm most excited about. And we have a whopping 6 languages this month. We have Ballerina, Pharo, Prolog, Red, Tickle, which you might know as TCL, but it's pronounced Tickle, and Unison. And each of these languages are quite different from the more mainstream languages. So we really recommend you try out more than one. Get a feel for how they're all different. It's not like, oh, I'm going to try a functional language this month. It's a set of different languages that all have different things going for them. So definitely recommend exploring them. I also definitely recommend Prolog because it's one of the languages I've enjoyed coding in most of my life. It's so different. It's so interesting. You know, for Mindshifting May, it really does shift your mind and change the way you think about code. So highly recommend Prolog. I know Erik's also really excited about Unison. That's got loads of interesting things in there. And Rebecca, one of the Unison team, has worked closely on that track. So that's another one that's good to try too. To get the Mindshifting May badge, you need to complete any 5 exercises in one of those languages during April. And remember as well, there's also the year-long 12 in 23 badge. To get that, you need to solve the 5 featured exercises in those languages. That can be any point during the year. So if you're watching this after April, that's fine. You can still do this bit and still get the badge at the end of the year. Choosing these exercises was really hard because the languages don't really have anything in common. They're so different. So we went with more generic exercises that are fun to solve and interesting to explore different approaches to. So firstly, we have acronym, where you convert a phrase to its acronym. Then we have isogram, where you're checking whether a phrase has repeating letters. Roman numerals, which translates a decimal number into Roman numerals, as the name suggests. Raindrops, which converts a number into raindrop sounds. That's a really interesting exercise. You can often do loads of refactoring and things. And space age, which is where you calculate how old someone would be on each of the different planets in the solar system. So all of these exercises and the ones for previous months, the list of those can be found on the 12 and 23 page. There's a little section you can see which ones you've completed as well. So check that out. Right, enough of me. I'm sure you're all more excited to hear Erik. So let's dig in and explore the languages. We're going to go through, look at each of them in turn, a few different questions similar to the last video, and then we will learn lots about them and hopefully give you enough information for you to choose which of the languages is that you want to explore this month. So let's start with my favorite, with Prolog. Over to you, Erik.
Yeah, let's start with Prolog. It's also one of my favorites. And one of the first things that you notice when you're doing Prolog is that it is a completely different way of thinking about your program. So if you're used to, I don't know, working in a C or a Java language, they're quite similar. They have an imperative outlook where you have variables and you have a flow basically. So you are basically directing the computer how to compute things, but Prolog is completely different. Your program is actually a set of relations between things. So, and you then query the relation database to find the result, but you don't really specify how you get to that result. You just specify the way in which those relations are defined, and then you ask a query, and Prolog will sort everything out for you to a certain extent, of course. But this is absolutely perfect if you have a rule-based system. The classic example is if you have a genealogy tree, so you have grandparents and mothers and siblings, etc. So you can have relations between them, and then you can query these databases with ease. And it's incredibly flexible and a completely different way of thinking. So it's logic-based programming. And that's something that you rarely ever see. And Prolog was one of the first languages to have this. And I think it's by far the most popular logic-based language that there is. Mm-hmm. Another great thing about Prolog is that it has very little syntax. So it has just one data type. It's called a term. And this data type is used in the other single language structural element, which are called clauses. And clauses are entirely built from terms, and they can define either facts, so things that are true, or rules. And rules are like, this is true when this holds. So this is the logic-based aspect where you define things as either being true or being conditionally true. And with just this little bit of syntax, Prolog offers you enormous power, and it's incredible what you can do with just these basic concepts. Prolog is also very declarative, which means that you worry less about how things are computed, but you worry about how things are defined. So how do you describe your problem? And then the actual finding of the solution, you delegate to Prolog. So in many cases, this means having less code. So the declarative aspect of Prolog, you'll figure that out very soon when you work with Prolog, because you'll just see that you don't worry about writing a for loop or anything like that, although you can use recursion. But in general, you don't bother with the nitty-gritty details and just hand it off to Prolog. The last thing I'd like to mention is that Prolog is designed to work well for querying very large search spaces. So if you have a lot of rules and you need to do some type of searching strategy, either depth first or breadth first, Prolog has got you covered. And Prolog has tons of optimizations to efficiently handle these large data sets. For example, by pruning paths, which means that Prolog can detect whether or not something could be true. And if it can't, it just completely skips that bit of the search space. So that's an incredible optimization.
Yeah, and, one of the... Oh, sorry. Go on.
No, that was it. That was it.
I was going to say, like, a lot of the fun I've had in Prolog has been like defining, like building games, or like building sort of programs that can solve games. So like taking something like Connect 4, you can define the rules of Connect 4, define different sorts of strategies or tactics that you're laying out and explaining. And then your program will work out what the next right move to do is. I remember having loads of fun back when I was at university with other people, and we'd all be making our own like Connect 4 solvers and then getting them playing each other and stuff. So it's really fun for that sort of thing. Like any exercises on the track that have those sorts of elements to them, I think will be really fun to solve in Prolog.
Yeah.
Unison,
Sudoku solver is also a classic example.
Sudoku solver is another classic one. Yeah.
If you ever written a Sudoku solver in a non-logic based language, it's not necessarily hard, but it's definitely a lot harder than what you do in Prolog with maybe just 10, 15 lines of constraints. It's just amazing.
Yeah, it feels like magic when you run your program and it just solves.
Feels like cheating.
It feels like cheating. It does. It's a good way of putting it. We could talk about this all day. Unison, Erik. I know you're excited about Unison as well.
Yeah. So Unison tagline is a language for the 21st century. So what their viewpoint is that programming languages haven't really changed that much in the last 70 odd years. So the way that we were writing COBOL is actually fairly similar to the way that we write code now in most languages. So Unison thought, hey, maybe we can apply the learnings of those decades and come up with a different way of writing code. And one of the ways in which they do that is that Unison code is in a database. Unison code isn't in text files, it's a database. And that's one thing that they do differently. There are other languages that do this. In fact, the next language that I'm going to talk about also does this. But the other thing that they have, and I'll come back to that later on, is that they have content addressed code, which sounds very fancy, but it means that basically the way that the data, your code, is stored in a database is to look at its structure. So if you have two functions that are similar, but they have different variable names, internally they will be exactly the same thing in the Unison database because they have the same structure. And that's the only thing that Unison cares about. And there are a lot of things that come from this property. So for one, there are no version conflicts in Unison code because a Unison function, when you call it, you're basically saying, hey, this is the hash of the function that I'm calling, and that hash won't ever change. So if somebody else updates a function, releases a new version, that will mean a new hash, but your code will still be referring to the old hash. So nothing ever breaks in Unison with versioning. So that's like mind-boggling. I don't know any language that has this, and I think a lot of languages would really, really love to have this. So this is an excellent property, and it comes from the fact that Unison is content addressed. So the hash of the structure of the code is what's stored. Unison also has a unique feature where you can, well, it's not entirely unique, but it is unique-ish, where you can support live coding in the developmental UI. So you add things to your code, and then it will immediately reflect in a UI. So you have live documentation. You can click through the source code easily. So even the source code of everything that's built into Unison. And it's all via a fancy UI. You can search for functions by definition, etc. So there is a lot of cool things that you can do with that, and come back to that later on. And finally, I'd like to mention that Unison is a purely functional language, and that means that in principle, you can't do side effects in functions, but of course your code must do side effects. So how do you handle this? And the way that Unison does this is by having something that they call abilities. And abilities are a way to manage effects in a purely functional way. If you've done Haskell, you will be familiar with the way that Haskell also treats this very explicitly within the type system. And Unison has a different approach, but it is similar to that in that you use the type system to encode the thing that can result in basically side effects, so I/O, etc. But you can use it for much more than that. So it's really, really flexible.
Nice. Pharo?
Pharo, yeah, Pharo is also called Pharo Smalltalk. So that gives you a hint of its inheritance, because it's basically, it started out as a re-implementation of Smalltalk 80. And Smalltalk is very well known amongst object-oriented aficionados as being the true object-oriented languages. So we know C++, Java, C#, all object-oriented languages. In fact, many of the modern languages are object-oriented, but it's originally Smalltalk was released in the 70s, in the beginning of the 70s. And it is also an object-oriented language because you have objects. But the way that you work with those objects is quite different from the other languages. And Pharo is a re-implementation of that. And one of the things that Pharo has, like Prolog, is that it has very little syntax. In fact, they have this very neat thing where they say the entire syntax fits on a postcard, and they have an image too of that postcard. So you can see that the entire syntax of Pharo is describable in an image that is like a postcard. It has just 6 reserved keywords. That's amazing. I know most languages will have dozens or maybe even 100. And Pharo just has 6. Wow. So the way that they have message passing as their core is also different from other object-oriented languages. Usually when you do with Java, you call a function or a method on an object, but in Pharo you send a message to an object, and that message itself is an object too. So it mimics almost like a natural language with a subject and a verb. So you send something and then you have parameters, etc. But it's all objects with, well, I wouldn't say that simple, but the semantics are quite simple. So it's not hard to understand what is actually happening in Pharo once you gotten over that little bit of a hump in the beginning, because it's sort of different from what you already know. But it doesn't mean that the semantics are hard. It's just that it's different from what you already know, which is perfect for this month. Productivity in Pharo is great once you get over that little bit of a hard start. And there are lots of reasons for this. Of course, the simple semantics and the little syntax help, but there are also some Pharo specific features that help with productivity, and we'll get to that later on. Pharo runs on most platforms, etc., on a fast virtual machine. And the thing that is cool about Pharo is basically a re-implementation of Smalltalk 80. So the version of Smalltalk that was standardized in 1980. But they have been evolving the language, which isn't the case with Smalltalk. So they basically are still at 1980. But Pharo is evolving. So it's sort of like what would Smalltalk look like if we applied recent knowledge to it. And it has a very friendly community, which is always very helpful.
Yeah, we've had nice interactions with the Pharo community over time. Cool. Tickle or TCL, depending on your preference.
I usually said TCL, but I have to say Tickle. So Tickle it is.
We've both been corrected recently by people on this.
I know. Yeah. So I should properly pronounce it Tickle. Like the two aforementioned language, it has very little syntax. So TCL has, they don't have a postcard, but they say we have 12 rules and they fit on a piece of paper. So that is also truly amazing, because that's just very little syntax. Like the aforementioned languages, the semantics are also fairly straightforward. So you don't need to know a lot about Tickle to figure out how things work. And this makes program easy to learn, easy to read. So it's a great language to pick up. Tickle also has some features that are actually very modern, although it is not a very new language. It does get updated regularly. And one of these things that Tickle has is that it has simple concurrency via coroutines, which, for example, C# is async await. Kotlin has proper Go routines. Go has Go routines. They're all variations of the same concept, and they allow asynchronous code to be written like synchronous code and more, but that's often where it's used best. So it's quite modern in that sense. It also has a built-in event loop for network programming and allows for asynchronous file I/O. So quite a modern language. So it is it's not new, but it is mature and still evolving. So I quite like that. Even though the language is not new, they are still adding new features, and they still have just 12 rules. So I think that's an amazing feature, actually.
Yeah, really impressive. And then a slightly more modern language, Ballerina.
Yeah, Ballerina. I think the first version was from 2021. And Ballerina is a language designed for the cloud. So if you want to run code in the cloud, Ballerina is perfect for that. They have first-class type-safe support for declarative processing of JSON, XML, and tabular data. So the declarative aspect means that, like Prolog, you define what you want to do, but not how you want to do it. So you are not bothered with the implementation details of going over a request and handling the internals, etc. You just say, hey, make a request. And there's also a thing that they call language integrated queries, which is almost the same as LINQ, which you might know from C#. And it's like having a SQL-like language in your language itself. So it's like this mini DSL. And it's perfect for getting data from a table or JSON or XML, and it's built into the language. Ballerina also has flexible types with structural typing. So structural typing is like duck typing. So if you have the proper fields, you can treat it as being of that type. This is also how, for example, JavaScript works. And they have closed and open types, so they deal with either too little data being sent or too much data being sent. And this all comes from the fact that they've really applied the lessons that they've learned when trying to build systems that integrate across the internet. So you have too much data that you get, too little data. How do you process that? And all these lessons have been integrated into the language. So built-in data binding and validation, of course, but also common integration patterns that you use when doing networking. For example, connectors, distributed transactions, which you usually have to rely on a library, etc., but they have it built into their language, and circuit breakers, so things that can go wrong, and then at a certain point you stop doing them because they probably won't be fixed anyway. So a lot of these patterns, the common patterns that you in other languages might have to code yourself or add a library for, Ballerina has that in the language itself. And they have other features like being automatically observable by any open telemetry tool. So that's great for getting insights into the application. They have great concurrency via, they call it strands, which are lightweight threads. So what often called green threads. So you can add a lot of those. Non-blocking I/O calls, etc. Compiler can help with detecting deadlocks, so basically preventing them. They have immutability, like a functional language, and explicit error handling. So it's all designed to work well in a networked scenario. So things will go wrong, you have to handle them, and you have a lot of freedom and flexibility when working with common data across the web.
I find Ballerina really fascinating. I think it's, I know it's evolving quickly. We had like a version of the track on an older version and they totally like changed it. I can't remember if it was like version 1, they totally changed things for, and we had to like redo the track effectively. But yeah, it's such a fast moving and interesting language. And I can imagine it getting a lot of adoption. Like all of those things you said, like it feels very powerful in the modern sort of cloud age.
Yeah, absolutely.
So, yeah, and then I guess the least mature of all of the languages, I think, still in alpha is Red. Tell us about Red.
It's still an alpha language, so that's the heads up at first, because it only works, for example, in 32 bits yet. They plan on going to 64 bits, but it's not there yet. But it's an alpha language, but it's still very interesting. It's very lightweight. The entire toolchain can be downloaded in 1.5 megs. Wow. So it's single executable. It's quite lean. It's very portable. You can easily cross-compile your code to different platforms, produces small binaries without dependency. So in that sense, it's akin to a systems programming language. A low memory footprint, so very performance friendly. And what's probably the best feature of Red is that it has a very good meta programming support. So it's Red code is actually defined in Red data types, which is something homo iconic, I think, and it's very well known in the Lisps, but other languages have it too, where you can read the code using the same data types that you're writing your code in, and you can transform them. You can do all sorts of really fancy things with it, and Red is excellent at doing that. And what I also loved about Red is that they have built in the reactive paradigm. So if you've ever written what's it called, observable JS or RX or whatever, it's a different way of programming where you listen to events and things propagate. So think Excel sheets, where if you update a value in an Excel sheet, you could have another field automatically be updated without you having to do anything. So this is a reactive way of programming where things are linked, and if something changes, other things will change automatically, and they have that built into the language.
Nice, awesome. I'll let you just take a breath for a second, Erik, before we dig into the next question. You just jogged my memory that again in the interview we had with Simon Peyton-Jones, he was discussing how he worked on Excel's programming language for a while, and that the one, it's a functional language, but two, that it's probably the most widely used programming language in the world, Excel, which is something I'd never thought of, which blows my mind. But just that example you gave there of that, I noticed last week as well in Google Sheets, you can now create like a live updating function. So it was for currency conversion. So you can sort of have a field and a value that's maybe in dollars, and then have a function that every 20 seconds is just automatically converting it to pounds or euros, whatever, in another cell, which I thought was just an interesting evolution of how these things work. So back on topic. So that was a great introduction. Thank you to all of those. What are the use cases for all of the different languages? Where might people, if they're trying to decide which language to try, where might they want to actually use some of these languages? Starting again with Prolog.
So Prolog used to be used quite a lot in artificial intelligence, and still is to a certain extent. And that's because many of these artificial intelligence systems, for example, expert systems, are all about rules. And you might have heard of IBM's Watson, the famous AI that won Jeopardy. So it has extensive knowledge about many different things, and it uses Prolog internally. So that's almost the highest artificial intelligence platform that you can work with, and they chose to use Prolog. So if you do natural language processing, artificial intelligence, Prolog is great for that. There's also the fact that if you have a very large knowledge base and you want to search it, Prolog is great too. So there's even a database, Terminus DB, that's implemented in Prolog, where you can search large knowledge bases for facts, and you can query them, etc. And what I found interesting is that Prolog's actually used in the definition of the spec of the Java virtual machine, so the JVM. So the JVM has Prolog definitions to specify the type rules. So these are built into the spec. So if you go into the Java virtual machine spec, you'll see Prolog references, and I find that quite interesting that they were using a fairly older language to define the semantics of the Java virtual machine.
Yeah, it's interesting, like on your first points around it being used for AI as well. So, 20 years ago or something now, when I did a degree in AI, and Prolog made up the bulk of the course. Like it was, it was how people were thinking about AI 20 years ago, and neural networks was one module in the whole of like a degree program. Whereas now, if you were to study, AI, it would all be machine learning stuff. It'd all be neural nets. And I imagine Prolog would sort of get a look in as like the older school way of thinking about stuff. So it's really interesting to think that it's in something like Watson as well, and how I imagine a lot of that is very quickly going to be superseded by machine learning and the large language machines, LLMs, that we've seen with ChatGPT. So it'd be interesting to see where Prolog's future lies now, and what other ways that we'll start to use logic programming if sort of AI has been taken in a different direction. Unison, where are we going to use Unison, Erik?
You're gonna write Unison, well, of course, if you want to try something really cool and new with some unique ideas, but more practically, if you want to write distributed systems, so systems that run on different machines, Unison is great for, and I'll explain why in a later section. So distributed systems are a great use case for Unison. Web servers in general are very good. So Unison is built with cloud computing in mind. But Unison is also very good for batch computing. And it's basically has Haskell-like syntax. So anything you can think of that Haskell would be good at, you can use Unison for. So computation, etc. And the purely functional aspects of it too are great for capturing side effects in the type system, which can rule out certain types of mistakes or uncertainties in your code. So a lot of different ways in which you can use Unison.
Nice. Pharo?
Pharo is great for having interactive tools. So you can see this in the way that it is used. For example, a defense industry company is using Pharo for its user interface and interaction prototyping, so rapidly trying out new ideas and getting immediate feedback. It's used in online trading platforms and cloud-based tools. There's a web framework too, web application planning, web-based planning, and another system for data exploration and an API visualization. So a lot of interactivity, and Pharo is absolutely great at that.
Nice. And then I guess Tickle's sort of more on the other end of the spectrum.
Yeah. So Tickle was originally intended as working like glue code, so combining existing systems, but it has evolved from that. And Tickle's also great to be embedded, so if you can actually include Tickle in your application and have it be used in a variety of ways. And Tickle's being used all over the place. So Cisco used it for its router GUIs. So there's a GUI framework, TK. It's a windowing toolkit that has been adopted by other scripting languages like Perl, Python, and also Ruby. There's Expect, which is a tool to automate interactive CLI applications. And it's also used in various manufacturing systems. NASA has used it on many occasions. And the list of large companies that use it is immense. So Pixar, Boeing, Intel, NBC, so many. So Tickle can be used in many different ways.
Wow. I didn't know that TK was built in Tickle. That's really interesting. And then I guess Ballerina is probably the most obvious, but yeah, where's that being used today?
You guess it, cloud native applications. So
Yeah.
you want to do the cloud, you want to, but also you don't have to necessarily have it run in the cloud. If you have local services too, that are using networking or are doing HTTP requests in general, Ballerina is great for that too. But cloud applications are the perfect use case for it. There's one application that's already out there by MOSIP, which is a foundational identity platform to help governments work with digital identity systems, but in a cost-efficient way. So it is already being applied in the real world, even though it's a new language.
Nice. And then I guess, like you said, Red's still in alpha, so I imagine trying to find anyone using it in production is quite rare. But yeah, do you know where that's going to be used? What's it trying to replace as a language, do you think?
Well, it's trying to replace Rebel, which is which its syntax is 95% similar to. But I haven't yet found a proper use case for where, well, at least a use case. I haven't found somebody already using Reb because it's still in its infancy. So we have to give it a bit of time. But for example, you could use Red to also write GUIs. So Red has a built-in, they call it dialects, and I'll get to that later. So it's like a mini DSL for doing UIs, and it's cross-platform, and it uses the native widgets of the OS. So you could easily see Red being used to write GUIs, but also you can write on a lower level, C-like level. So there are many different ways in which you can use Red. It's just that I haven't found anybody yet using it, but that could also be me.
So one of the interesting things about the languages this month is that the use cases are really different and the concepts are really different. So, like, obviously, yeah, interesting to think about the use cases. What about the programming perspective? If you're looking to choose one of these to program in, what are the different considerations? Are they functional? Are they OOP? Prolog is probably the most obvious, but yeah, do you want to just tell us a little bit more about what Prolog looks like to code in?
Yeah, Prolog is a logic-based programming language. It's the only one that we have. It's its own complete different paradigm. So if you know OO or functional programming or imperative coding, Prolog uses a different paradigm. So it really, really is different. But it's a lot of fun for that too. And Prolog is dynamically typed, so it's almost like a scripting language at that, but it isn't really just a scripting language. So Prolog is just in its own, it's one of its kind. It's just really unique, but it's mainly for doing logic programming languages. And there are things like recursion that you for example, see in functional languages a lot, but it is a logic programming language.
I feel like it's quite an easy language to learn recursion as well. If you have struggled with recursion, I feel like programming in Prolog is a way of recursion making sense because of the way you're writing it. Unison, what's that like to program in?
Well, Unison is a functional language, but it's actually a purely functional language, like Haskell. So this means that side effects aren't allowed unless you use the abilities feature of Unison. So it's a functional language. Doesn't do object-oriented things. It's just functions. So if you like functional programming, Unison is great for you. It's like Haskell. It's a statically typed language. So basically, if you think if you like Haskell and strongly typed compile functional languages, you'll really like Unison.
Does it feel like Haskell to program in?
Yeah, it has definitely been inspired by Haskell. So it feels very Haskell, yeah, to me.
Then on the other end of the spectrum entirely, we have Pharo.
Yeah, so functional on the one end, object orientation on the other end. So Pharo is an object-oriented language, but it's an object-oriented language in the Smalltalk sense of the word. So when most people think about object-oriented language, we think about a Java or a C Sharp. But Smalltalk and Pharo are actually quite different from those languages. I mentioned before that you don't call methods, you send messages to objects, and those objects can reply. And that messages themselves are objects. Everything is an object. And that's the case in many languages. But if you compare this to other languages, Pharo doesn't have constructors. There are no type declarations, no interfaces, no primitive types. So it is object-oriented programming, but it is very different. So if you like object-oriented programming, I would recommend you try out Pharo, because maybe you like their interpretation of object orientation more. So there's a famous quote somewhere about C++ not being the way that object orientation was envisioned by the original creator, but well, we'll not go into that. No. Pharo is also a dynamically typed language, so that's quite different from many object-oriented languages, which are statically typed. So it really is a different way of looking at object-oriented code.
If you've used Ruby at all, like Ruby sort of sits somewhere in between the two. So Ruby has no primitives.
Yeah.
You send messages, but I feel like Smalltalk and Pharo just take that so much further.
Yeah.
So yeah, think of this on one end, C# maybe on the other end, or Java on the other end, and then something like Ruby sitting in between the two. Tickle?
Tickle is a multi-paradigm language, which means that you can program in different ways in Tickle. So you can use object-oriented approaches, imperative approaches, but also functional approaches. So you can basically choose which style you like best. And it's a dynamically typed language, which it's almost like, it feels a bit like a very scripty language. So in a way, it resembles Bash a little bit, albeit more powerful and far more elegant than Bash, in my humble opinion. So Tickle you can use in a variety of different ways, whichever you like best, I think.
Ballerina?
It's also a multi-paradigm language. So you can use object-oriented features, functional features, declarative features. I would say it is mostly a declarative / functional language, but you do have classes with methods. You have a bit of immutability too, so that's quite on the functional end of the spectrum. It's a statically typed language, runs on the JVM, and you can use it for different purposes and in different styles. So once again, you decide which style you like best.
It feels a bit strange to me that it runs on the JVM. Thinking of like wanting to pick it up and just move it easily and lightly around the cloud, the JVM feels like a really heavy thing to have to be able to do that.
Yeah, but the JVM is also incredibly optimized, so it's quite performant actually, even though it doesn't have that reputation. Yeah. And the JVM, of course, offers a lot of built-in functionality and built-in libraries, so you can interrupt with jars that have already been built. So, yeah, I'm not sure if they will keep it like this, but I expect they do, because, well, it'll be hard.
Yeah, hard to move away from.
Yeah.
And then finally, Red.
Once again, a multi-paradigm language. So you can do imperative programming, object-oriented, and functional programming. But what they also have, and they call it symbolic programming. And Prolog has this in a way too, where you can work with the code. So I mentioned that you have features that allow you to read the code that's being compiled before it's actually being compiled or interpreted, and then you can transform it like a Lisp, and that's what's called symbolic programming. But they also have reactive programming, as I mentioned, the Excel sheets like functionality, which Some languages support via libraries, but it's rare to see it built into the language. So Red does have that. And it's another statically typed language.
Okay. Cool. So that's a quick overview for everyone about the high level way of that you'll be programming those languages. What about from a slightly deeper way? What are the standout language features? What makes these feel unique to programming beyond sort of just the use cases? So again, starting with Prolog.
Yeah, so I think this is where it gets really interesting, because all these languages have standout features that are really different from other languages. So for Prolog, one of them is that it's really, really flexible. And it is flexible in ways that you might not be used to. So you have predicates, which you could see like sort of being like functions, but they're not really. So you can define a relation via predicates. So if you have a list append, so you get two lists as input and you get another list as output. So normally that will be like a function with two arguments and one output. But in Prolog, that's a relation. So if you have a list A and a list B, then the list C, if you have that as a variable, it gets populated with whatever is appended from A and B. But you can also put have the variable be the middle of the predicate, so the second list. And then you have like the end state, a begin state, and Prolog will figure out what the middle variable is to fulfill the relationship. And that's, it might sound really weird, and I might not be explaining it that well, but do try out the Prolog track and see if you can get used to this fact, because it is incredibly powerful. And you can basically see it as a function that works both ways. So you can start from inputs, but you can also start with outputs, etc. So it is incredibly fascinating, and it is incredibly flexible too. This gives you a lot of power in your Prolog code, and you can query and create data with the same syntax. And this also means that it's what I meant with feeling like a cheat code. So some problems that are quite hard in other language, in Prolog they're just trivial. You get them for free, and this is an amazing feature of Prolog, and you will really appreciate it if you've been doing Prolog for a bit. A second standout feature is that Prolog has a thing that's called DCG, and we don't care about the acronym for now, but it's basically, if you know, a parser combinator, which is like you define rules, and those rules can be used to parse text. So if you have a certain data format, you can define rules that says, hey, this line has to start with 10 letters, then a colon, and then whatever. And you can define these within the language. So they have the DCG allow you to define these rules very elegantly. And the Prolog flexibility gives you, you can use these rules to parse things, but you can also use these rules to generate things. So basically the other way around. And you can even check sequences if they match. And it is incredibly flexible and very liberating to have some things like this. So if you treat the text as a list of characters, you can see that, for example, you can transform all these rules into working with lists. So you start with 10 letter items, and then you go to a different rule, etc. So it's really powerful. And in many languages, you have to resort to libraries for these types of features. But in Prolog, it's built in. And then there's a third thing that's really neat about Prolog, which is CLP. So that is a way in which you can define your program as consisting of constraints. So you're saying, for example, if you have a parameter, you're saying this parameter must be in the range 0 to 10. And then you have a second parameter, and you say, hey, it must be greater than the first parameter. And then Prolog will infer certain constraints, and it will restrict the search space. So, for example, we had a mention of solving a Sudoku, and you can see a Sudoku as a constraint solver. So you say that, for example, everything in a single column must be in the range 1 to 9, but they must all be different. So those are two constraints. And then what the actual the solution is, you just hand off to Prolog. And CLP is a very efficient way to think about these programs. And you can solve things in different ways in Prolog. You can use the regular way, but many programs can also be solved in a constraint-like way. And once you get used to that, that's incredibly powerful and really, really fun too, I would argue.
If you've done things like pattern matching with guards and things like that on functions and maybe something like Elixir, it's sort of along those lines, but just so much more powerful. And the way that you program in Prolog, it's not like one feature, it's like the thing that is the very core of the language. So yeah, it's you definitely need to try Prolog. I think both Erik and I could just sing its praises and chat about it all day. Unison, Erik.
So I briefly mentioned this, but in Unison, code is not text, but immutable data. So this data is stored in a database. It's actually at the moment a SQLite database. I don't know if they ever changed it, but it's funny to see that there's just a database with your code. So you don't have the files, you have just one single file. Great for backup too. And you can access that code and update it via the Unison Codebase Manager, UCM. And that's an application, like a console application, where you can browse through your code, you can search through code, you can update code, you can run tests, etc. The text files are basically a way to get data into the database. So you can throw them away afterwards because they're stored in the database, they're not stored in the text files. So text is just a one way of getting data into the database. You can also do it via the Unison Code Manager, of course, but yeah, text files do have a couple of nice things that where the Unison Codebase Manager watches them for changes, etc. So you can use them as a sort of scratch files too. And a nice feature of this storing storing code as data, as immutable data, and means that immutable data doesn't ever change. So if a function changes, it will have a different hash. So the old function will always remain in the database and its hash will never change. And this also means that if you have code that runs test on a specific bit of code, so a specific hash, those test results are valid forever. Because if the function changes, it will be a new hash. So you will run the test against that new hash. But the test against the old hash, they will always be valid because, well, it can never change. It's immutable. So you can cache your test results. And that's actually quite funny if you do Unison code. Now I was updating things and I was doing a bit of refactoring. And Unison told me, hey, you didn't update anything because it was the same immutable data. So running the test was just instantaneous because the data could be cached. So quite funny to see that refactoring didn't actually change my hash sometimes. Sometimes it will, of course, but you never run the tests twice. So it's an environmentally friendly language, I'd say. So definitions are referenced by hash, so not by name. So if you have a bit of code, a function, it will have a hash, and you refer to, you might call a name in your code, but internally it will link to a hash of that function. So content addressed. And the syntax tree of the code is what determines the hash, I told you. But this has no version conflicts, but also renames are trivial. So if you rename a function, well, that's just easy. That's will always be allowed because no code will ever break because the code doesn't depend on the name. The code depends on the hash. So you are free to rename or I don't know. You can even move it to a completely different namespace or whatever. It's all entirely possible in Unison without breaking anything. Unison docs are a first-class entity too. So you might know this of, for example, an Elixir. So you have documentation that are in sync with the functions because it's linked. So I mentioned that you have this local UI, this web UI that has an overview of your code. And this is always up to date with the latest version of the code. You can embed live examples in your documentation and see them in the documentation appearing in the UI. And you can assure that your example code compiles. It will be checked. So functions of documentation is a first-class entity in Unison. And finally, Unison is perfect for cloud computation because there are no builds. So if you are working with Unison code and it has a syntax error or typing error, Unison will, of course, tell you that, but you can't commit code to the database that is in a bad state. So only when you've actually fixed the code, you will get to commit it to the database. And at that point, the system knows that, well, it's correct and it will always be correct because it's immutable. So there are no bills. You don't have to check whether or not everything type checks, because otherwise it wouldn't be in the database anyway. And this means that, for example, everything that's in the database can be distributed on the fly. So you can send hashes, and then if you do a remote procedure call, this might be a bit of an exaggeration, but you could send the hash, and if the others and the arguments, and if the other side has the hash in their database, you don't. You're already done. So you don't have to. It doesn't have to have the same name, just the same hash, and then everything's fine. So it's great for distributing and doing remote procedure calls. You don't have to spend as much time on writing encoders and decoders for Unison, because they have a way of handling that gracefully for you. So doing cloud computing is great in Unison, basically.
Nice. I can tell that you're excited about it and interested in it. Okay, so Pharo, what's interesting to do when you're in Pharo?
So one of the things that I find incredibly fascinating about Pharo is its straightforward execution model. Everything's an object, and there are more languages that have that, but what not all languages have is that even execution happens via objects, which are called messages. So messages are objects too, and classes are objects, etc. Everything is an object, like in Ruby. But also control flow is done via messages. So it is different from the way that you work with other languages, and it's a fairly simple model at its core, but it is very powerful. So I find it almost a relief to see that you could have a very simple model while still being very powerful. So you don't need to have all these bells and whistles to have a very powerful system. Pharo is fairly simple, but still very powerful and quite different from other object-oriented languages. A second thing about Pharo that I really like is actually quite similar to Unison, in that the code resides not in text files, but somewhere else. In this case, in Pharo, it resides in a Pharo image. But there are some differences from Unison. So a Pharo image is basically a snapshot of your application's entire state. And it can be executed in the Pharo virtual machines. So when you save work, Pharo saves it to the image, but it's the entire state. So all the objects that have been created, all their relations, and the execution context, it's all there in the image. So it's like a minimal image of everything that you have in your code base. So it's not just the code, it's the object, it's the relationship. So it's the state of your application. And you can then share this with others, and you can load it on different platforms. But it's a completely different way of thinking about things. And the way that you work with these images too, you can do that via this specific Pharo IDE. It's called Pharo, and you get live feedback on the state of the system. You can inspect things. You can update things at will. So while your system is running, you can update things, and there are not many languages that allow you to do that. So and it has a very powerful debugger where you can rewind things. You can and if the debugger could, for example, see that you sent a message to something and that something doesn't respond to that message, and it says, hey, do you want to create that method maybe? And then you can just fix the bug instantly. The debugger will help you with that. And it's a completely different way of working with your code, where you have your working database or your production database image, and you can just inspect all these objects and see the state. So it's very different from the way that we're used to working with code.
Nice. Tickle?
Tickle. I like that Tickle has a very straightforward type system. It used to be the case that in Tickle, everything is a string. So that was how it used to be implemented. Under the hood, though, there is now a robust type system. Tickle has evolved. And there's a Tickle entity, for example, strings, floats, integers, or dictionaries. They have a type-specific representation as well as a string representation. And this is, of course, done to improve the performance. But you could still sort of get away with thinking about like everything is a string. And it's a very, very interesting way in which you can write code that is very, very generic and very flexible. So you can work with strings, and a string could be a method call or a function call, and you could just evaluate the string. So it's very dynamic too and very powerful. You don't really have to convert back and forth from strings internally. So it is more performant than that. But as the mindset, everything is a string still sort of works. And now that we're speaking of everything is, in Tickle, everything runs as commands. So there are no built-in commands. Tickle ships with a standard library of commands, and these include if statements and while statements, but it's very easy to add new control flow commands. For example, an until loop. You could even remove commands. So if you don't like ifs, you can remove ifs. I'd not recommend that, but you can. And you can override commands. So if you want to add some, I don't know, some logging to each time you run an if loop because an if statement because you don't like them, you could do that. But the very fact that everything runs as commands is very powerful because it's once again it's just one way of doing things. Once you grasp that, you grasp the entire semantics of the language basically. So and as the language is very compact and the semantics are fairly simple, paired with the fact that Tickle is implemented as a C library, means that Tickle is quite easy to embed in an application, and it's often used for that too. So if you have a C application or something that can have C code in your application, you can embed Tickle quite easily.
Nice. That's really, really interesting. I like having a language that doesn't have any of those sort of control flows and stuff in them it's fascinating. Isn't it? What about Ballerina?
Yeah, Ballerina is cloud native, so everything is designed to work well in a cloud scenario. So you have built-in conversions from JSON to your user-defined types with all the error handling that you need to look out for. There's a very lightweight syntax for creating microservices. It's really, really, really lightweight. You have built-in concurrent execution of services, so things running in parallel. It's out of the box. It supports HTTP 1 and 2, GraphQL, gRPC. So many of the web protocols that you are using or want to use are natively supported in Ballerina. So it's perfect for cloud native basically. Another way in which it is excellent for cloud work is that you can automatically generate artifacts to deploy your code into different clouds. So you could, for example, say, hey, generate Docker files from my code, or Kubernetes YAML files, or serverless functions. And that's built into Ballerina itself. You don't have to do anything for that. They will do it for you. And I quite, as having written quite a lot of Docker images already, I quite like that. And I think you would appreciate the serverless functions too.
Yeah, that could save us a lot of time. Just thinking about how many hours are spent just refining Docker files in life.
Yeah. And I think that's it's fairly unique to Ballerina is that it supports visualizing the code as a sequence diagram, which you might know from your from UML. So a sequence diagram is in essence just a flow diagram where you start at some point, then this happens, etc. But it's great to give you an idea of how your code actually works and what is the order in which things are executed, etc. And if you install the Ballerina plugin in VS Code, you can just press a button and you can see a visualization of your code. And that will include HTTP calls too. So it will detect that a request is made to the internet. And that's all. I haven't seen that, I think, ever. Probably there are languages that do something similar. I sort of remember some UML tools doing that, but a newer modern language that allows you to generate a sequence diagram, it's quite powerful.
You're showing your age by talking about UML, Erik. I reckon.
I know.
If you've been developing for less than 10 years, I reckon you probably got.
It used to be the thing.
It did. There was a point where everything was going to be UML.
Yeah, I still have nightmares about rational rows.
Yeah, I haven't. I've come across maybe libraries and things that do that before, but having something that's built into the language like that is That's super powerful. What about red? Final one.
Yeah, red is great for building or parsing domain-specific languages. They call it dialects, and that's actually Rebel terminology, but they've adopted that. And there are several built-in dialects in red. So there's red/system, and that's a C-level system programming language, and that compiles to native code. And then there's parse, and I mentioned a parser combinator for Prolog. Red has that too. So red has parse, which is a very powerful PEG parser. It's a type of parser. Don't bother with that. But it's great for parsing things. So data formats in different ways. Parse is really powerful. There's vid, which is a GUI layout creation dialect. So building GUIs with red. You do that in a specific DSL, a dialect, that makes it easier to build those languages, those GUIs. Draw is a vector 2D drawing dialect, and there's a rich text dialect, and you can even build them yourself. So if you are working with domain-specific languages or you want to build them, Red has you covered. And as I mentioned, you can use Red to build GUIs, and the way that they do support it is fully cross-platform and native. It supports many different things that you would want when you're building GUIs, like two-way binding, live updating, events, and it provides access to the OS's features.
Nice. So final question then. If somebody is trying to choose one or maybe two languages to do during Mindshifting May, how would you recommend to them that they choose those languages? What would your guidance be?
Good question. They're all interesting languages in their own right, so you could make an argument for any of them. But some things that you could think of is, for example, if you're interested in cloud computing, Ballerina and Unison are obviously great choices. But TCL has great concurrency features too, so you might want to try out that. If you are familiar with object-oriented programming but want to see a different take on it, I'd highly recommend you try Pharo. And even if you haven't done any object-oriented programming, try Pharo to see what object-oriented programming is like. If you want to have some language do things differently in that you program not necessarily in text files, then try out Pharo or Unison with their unique ways in which you work with code. If you like minimalism, so languages with little syntax and simple semantics, TCL, Prolog, Pharo, and Red all have fairly little syntax and relatively simple semantics. So that makes those languages somewhat easier to learn, although they might be different from what you know. So there will be a little startup issues, but they do have very little syntax, and that's always great when you're learning a new language. If you want to have an interesting blend of paradigms, Ballerina, TCL, and Red all support different paradigms. So if you want a language where you can try out different ways of doing things, those are great languages. If you want to try out more unusual paradigms, I recommend trying Prolog for logic programming, Red for reactive programming, and Ballerina for declarative programming. If you like functional programming, try out Unison, and in particularly its abilities to capture side effects in the type system. And if you want to do some meta programming, TCL, Prolog, Pharo, and Red once again all have great meta programming support. So if you if you like your meta programming, try out those languages. And of course, if you have the time, I would really recommend. I think this is the month I would really recommend you doing it, to try out a couple of different languages. They're also so unique. So if you try out a couple of them, you can maybe even select one exercise that's in all of those tracks. So try the 5 featured exercises, or maybe one of them just, but in different languages, and see how the languages require you to think differently about a problem.
Yeah, totally agree. Really interesting month, I think, as I said at the beginning, the one I'm most excited about digging into as well. Thank you so much for putting all that together, Erik. Your wisdom is impressive as always. Everyone watching, I hope you have a really great month. Enjoy it. Please leave a comment in the video below and tell us what you're interested in, what you're going to try. We've also got some new stuff coming this month. We've got Dark Mode and ChatGPT both launching later in the month. We've got Exercism Insiders and some other bits we haven't talked about yet. So we've got lots of stuff coming up. Yeah, keep your eyes peeled for all of that. Have a great month and see you on Discord or on our forum. Thanks for watching.